Hi, and welcome to Meetings in Math. You are here for section 7.2, Finding Cube Roots. Our essential question for today is, how can patterns from finding square roots be used to find cube roots and other roots? Today you will need your Jaguar dots on section 7.2, a pen or a pencil. You may find a highlighter useful, but leave those calculators behind and replace it with a multiplication table if you need it. Make sure you bring your bright ideas, your best effort, and as always, your problem-solving skills. We're going to begin this lesson by recalling the rules for finding square roots of numbers to help us with cube roots. So we're looking at three scenarios: the square root of 36, the opposite of the square root of 36, and then plus or minus the square root of 36. So let's begin with the square root of 36. So when we have this, we want to take 36 and we want to break it into the prime factors or into at least twins. So we know that 36 is 6 times 6. That's enough. If we remember our story about our mystical forest, we are trying to escape this mystical square root forest. And the only way to get out is to have a twin. And so our 36 really looks like 6 times 6. And as we go through the tree, which is our square root, one of our twins disappears and the other one can actually leave. It's not a great story as far as happy endings, but it gets the job done, and it helps us remember that we only get to keep one, and then the other one goes away. Now this one is saying take the opposite of the square root of 36. Well, since we know the square root of 36 is 6, the opposite of it is going to be negative 6. And the last one is saying plus or minus the square root of 36. And so we just need to remember to put the plus or minus in. So now this gets us back to this question. Can we do the square root of negative 36? And the answer is no, because there's no real solution. And why is there no real solution? Well, that's because we have to remember that when we are doing squares, the square, taking negative 6 squared is negative 6 times negative 6, which is 36. And 6 squared is 6 times 6, which is 36. And squares and square roots, those are inverses of each other. So there's no way for me to get negative 36 when I multiply the same number times itself. But when we get into cubes, that story is different. The cube of 2, which is 2 to the third, which is 2 times 2 times 2, looks different. These are triplets. So 2 cubed is 8, and 8 is 2 times 2 times 2. The cube of 7, which is 7 cubed, which is 7 times 7 times 7, again, those are triplets, is 343. 7 times 7 is 49, and 49 times 7 is 343. Why do we care? Well, when we want to do the cube root of 8, we're going to break it into triplets. This number right here tells us what kind of quote-unquote magical forest are we in. Are we in a magical forest that takes triplets to get out? Yes. The square root one is our standard magical forest. That's why there's nothing on it. So it's a little table and then the check mark and then the bar over it. Please make sure again that you're doing the check mark and the table, otherwise you're making a division sign. So now it's the cube root of 2 times 2 times 2, and we're looking for triplets in this case. So it's really important that you understand that you are looking for triplets. And in this case, 2 are going to go away and only 1 comes out. So our answer then is 2. So what happens when I have the cube root of 1 over 343? Well, in the same way that square roots let me split up a fraction, I get to do the same thing with cube roots. So I'm going to take the cube root of 1 and the cube root of 343 and do that. And so I'm going to break my triplets of 1s, okay? So I'm going to have 1 over, and then my triplets of 7, and I'm going to have 7. So again, what did I do? I took my 1s right here, and 2 of them are going to vanish, and my 7s, and 2 of them are going to vanish. It's because I'm taking the cube root. And a cube root is just saying, what did you multiply out by itself? I multiplied the 7s out. I multiplied the 7s out, and I multiplied the 1s out. So I had groups of 1s and groups of 7s. So let's look at the cube root of 729. So just like I did with square roots, I'm going to make a factor tree. And this time though, instead of looking for twins, I'm going to look for triplets. So 729, I happen to know that 7 plus 2 is 9, and then 9 plus 9 is 81. So I know it's divisible by 9 by my divisibility rules. And so it's 9 times 81. And so 9 I know is 3 times 3. And 81 I know is 9 times 9. So I'm going to keep bringing my 3's down, so I'm only looking at one level when I'm done. And 9 is 3 times 3. And I have 3 times 3 again. So I have 1, 2, 3, 4, 5, 6 3's. So then I'm going to come over here, and now I have the cube root, and then I have to write this down 3 times. So 1, 2, 3, 4, 5, 6. And see how my bar doesn't go over all of them? I need to extend it out and make sure it does. And now this time I'm looking for groups of 3 at a time. So here's a group of 3, which means I'm going to write it down once. And then I have another group of 3 right here. So I'm going to write it down another time. So now I have 3 times 3, which is 9. So the cube root of 729 is 9. So that means if I wanted to check it, I would do 9 times 9 times 9. Well, 9 times 9 I know is 81. And 81 times 9 I know from what I did up above is 729. So what happens when I have a negative number? Well, we need to be really careful is what happens. Because our answers, the things that we're multiplying, need to be exactly the same. So I have 512. And you know what? I know that 512 is divisible by 2. And that's about it. So 2 times 256. And then I have another 2. And 256 I know is divisible by 2 and 128. And 128 I know is divisible by 4. How did I know it was divisible by 4? Because I know 28 is divisible by 4. And if the last 2 digits are divisible by 4, the whole number is divisible by 4. So 4 and 32. And so this is a 2, another 2, and 4 I know is 2 and 2. And 32 I know is 4 and 8. So depending on how good your multiplication skills are, you're going to get through these faster or slower. If I had to keep on multiplying by 2, I just keep multiplying by 2. It just takes me longer. But I'm going to keep pulling these 2's down. And 4 I know is 2 and 2. And 8 I know is 2 and 4. At one point you'll get really good and you'll just call 8 a 2, 2, 2 because you'll just know it. So I know this is 2 and a 2, 2 and 2. So now I need to count up how many 2's I have. I'm going to switch to a different color real fast just so I can count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now I have to make sure I do the cube root of them. So make sure I have a cube root over them. And now I have to go pick up 3 at a time. So here's my first 3. Whoops, that's not supposed to be 3. It's supposed to be 2 because that's the number that's in the box. There's my second. And there's another set of 3. So 2 times 2 is 4. And 4 times 2 is 8. So the cube root of negative 512 is 8. Oh, there's a huge mistake here. And this is why we are doing this problem. The reason that we are doing this problem is because everything in there has got to get to that negative 512. So we have to make sure that this is going to happen. I would have done the problem exactly the same. It's just that these right here, you have to make sure that you end up with a negative answer. So these were all negative 2's. And then this is a negative 2 times a negative 2 times a negative 2. We'll put them in parentheses this time. So negative 2 times negative 2 is positive 4. And then this is a negative 2. So this is a negative 8. So we can have negatives in cube roots. We absolutely can. We just have to be super careful. Technically, when I was making this over here, I probably should have done this and then that and had this negative follow all the way through. It gets super confusing. The way that I typically do it is I take care of it at the end. I know that if I have a negative here, my answer will also have a negative. So what do we do when we have a problem with its fractions? We just have to do those two separate factor trees and then put it back into a fractional answer. 125, I know, is 5 times 25, which is 5, and then 5 times 5. I'm actually going to just do my triplets right here because I can see it so easily. I see that there's a set of triplets, so my answer is going to be 5. The other one was 343. I know based on work we did before that this was 7 times 49. So 7 and then 7 times 7. There's my triplets, so this is going to be 7. So sometimes you can even do finding your triplets on the bottom of your factor tree. So this is going to equal, let's go ahead and show it the work. The cube root of 5 times 5 times 5 over the cube root of 7 times 7 times 7. So then it ends up being 5 sevenths. So in this last one, the volume of a cube is volume equals sides cubed. So if the volume is 512 centimeters cubed, what is the side length? So start off with what you know. So what we know is the formula, and then just list out the variables and then plug in what you know. They tell us that the volume is 512. So then let's put the volume in there for 512. And what we're trying to find is the sides. So substitute in what you know into the formula. So 512 equals s cubed. Well, if undoing a square is a square root, then undoing a cube must be this funny cube root thing that we've been doing. So we need to then to do the cube root of 512. But we just did the cube root of 512 on the other page. If you remember when we did it, we got down to the very end and we ended up with the cube root of 512 was equal to 2 to the 9th. So 2 to the 9th looks like this. So now we are going to look for our triplets. So we have a triplet here and a triplet and a triplet, which ends up being 2 times 2 times 2 equals s, or 8 equals s. So each side is 8 centimeters long. So now what I'd like you to do is I would like you to create a problem where the answer is 6 times the cube root of 5, or 6 cube root 5, and explain to someone how it is that you did it. Thank you so much for showing up, and remember, this will take time to understand, but if you continue to practice problems, you will get better at it. Thank you so much for showing up, and remember, be kind to one another because we all can use some extra kindness in our lives. Bye for now.